Okay, so let's start talking through this here. So this section is going to build off of what we've been doing the past couple days. So a couple days ago, the one that you guys watched on the video after the quiz, we just did basic inequality graphing, right? Where we got the line, did our shading one side or the other. And then yesterday we did the systems, right? Where we did basically multiple lines. Sometimes it's two, sometimes it's more, where we were graphing them, and then we were doing our shading, and we were seeing where it's like double shaded or like shaded by all of the different sections. So basically, this linear program section is the same thing as what we were doing yesterday, except for once we get our feasible region and like the vertices or like the spots where they cross, we're just going to actually do some stuff with that. I don't know why it's called linear programming. I'm sure it says in the book here what it actually is. It seemed kind of confusing, so I just didn't read it. But basically, all our goal is to minimize or maximize our values. So depending on what our situation is, either you want high values or low values. So like you would use this if you're trying to like calculate like profits of something. So like you remember yesterday we were doing that flower example when we were selling flowers. If our goal was to figure out like how many of which type of flower we should sell to maximize our amount of money we're making, we could use this process. So we'll do some examples with that. So you can do it for like money. You could also do it for like amount of materials you've got. Like if you've got so much materials, like what's the best products to make with those and how many of each and that kind of thing. But like I said, you'll see it when we do the example. And then it kind of gives those steps out there for minimizing or maximizing our values. So we're coming up with our system first, just like we were doing yesterday, coming up with those inequalities. Then we'll graph it, figure out our feasible region. So again, that's just our double shaded area. And then today we're going to focus more on the vertices or the corners of that feasible region. And then we're going to use that to figure out either maximum values or minimum values based on an equation that usually it deals with profits, but you can do it for other stuff too. Okay, so let's look at that first example there. Everybody get that extra sheet? Okay, so on that extra sheet there, we got Lisa makes necklaces and bracelets in her spare time and sells all the stuff that she makes. Each week she's got 10,000 grams of, that should be of, metal, and she's got 20 hours to do it, and then they turn 20 hours into minutes just because the other stuff's in minutes there. To work, and then it takes 500 grams of metal for a necklace, 50 grams for a bracelet, and then each necklace takes 30 minutes and each bracelet takes 15 minutes. Okay, so the first thing they're going to want us to do there is to make like our system here. So they tell us N is necklaces, B is bracelets. They give us the ordered pair there, N and then B, so that would mean our N is in the X spot, so that'd be going across the bottom. B is in our Y spot, so that'd be up the side. And we're supposed to figure out, Lisa can make, so find the vertices for that region and then for how much you can make each week and draw the graph of that feasible region. Okay, so let's start with the system here. Okay, so we are going to have one of these that deals with the materials and one of these that deals with the time. So materials wise, we've got a total of 10,000 grams of metal. We got 500 grams for a necklace, 50 grams for a bracelet. So I'm thinking we probably go 50, or not 50, I'm going to go 500 with 500 was the necklace. So 500 N plus we'll use up 50 per bracelet. So 50 with the B. And then total grams there, we've got our 10,000. Okay, so then symbol-wise in the middle here, what do you think? Do you think we should eat towards the 10,000 or do you think we should eat towards the other stuff? What do you think? Should we go over 10,000 or not? Probably not, right? So if we don't want to go over 10,000, which way should we eat? You're backwards to me, Braden. Eat towards the 10,000 or the other one? The 10,000, right? Because we would want that value to be our like top value because we don't want this value to go over that, right? Can we hit 10,000? Can we equal it? Yeah, that would just be us using up all our materials, which would probably be a good thing, right? Okay, so that's our gram stuff for our materials. Now we're going to do the same thing with the minutes. So we got 30 minutes for a necklace, and we've got 15 for a bracelet. So add those for our total, and then we're going to use that 20 hours in minutes since those are both in minutes. And if it wasn't in minutes, you just take it times 60. So 1,200 there. Okay, and then again, same situation. Which way are we going to eat to? 1,200 or the other stuff? The 1,200, right? Because we don't want to go over the 1,200. We want to be under that because that's how much time we've got. And then can we equal 1,200 or not? Yes. Yeah, we could, because that would just be using up all of our time, which again would probably be a good thing. Okay, so then those are the two main ones. Then we want to do the same thing as we had yesterday when we don't want to include the negatives. What did we do when we didn't want the negatives? Anybody remember what those little inequalities were? What do we have to be bigger than? 0, right? So basically we want our bracelets bigger than 0 and our necklaces bigger than 0 because we're not going to have negative bracelets, right? So our bracelets would be greater than or equal to 0. System line's kind of not there. And our necklaces, same thing, because we're not going to have to worry about negatives. Now we could have 0. You could have 0 necklaces or 0 bracelets, but nothing in the negatives. Okay, so that's our system. Now we got to go about graphing those guys. So here, up to you how you do it out. You can do the x-intercept, y-intercept thing we did yesterday. You can also do like y equals mx plus b. When I did it on my sheet, I did y equals mx plus b, but it really doesn't matter. What would be our letter that represents y in this case? The b, right? So the b for the bracelets would be like y, when we're going to graph. So there, if we're doing that method, we're going to solve both of these top ones for b. So I'll just do that off to the side here. So if we did like 500 n plus 50b is less than or equal to 10,000. If we need to solve for the b, because again, that's kind of like our y equals, we would subtract 500n. That's gone, so you have 50b is less than or equal to, I'm going to put the negative 500n at the front, plus 10,000, and I leave myself a whole lot of room there. And then to get rid of the 50, divide by 50. When do we have to worry about our sign in the middle there? Changing ways. If we're doing what with a negative? Or multiply. So if we ever multiply or divide by a negative, we got to switch that sign around. Here it's going to end up being a negative over here, but because the action we did to both sides wasn't negative, we don't have to worry about that, so that just goes away. So symbol will just stay as is. Negative 500 divided by 50 would be negative 10. N, and then 10,000 divided by 50 is 200. So now we can use that equation to graph instead of using that top one there. They're the same thing, but it'll just be easier for us to mess with. And then I'm just going to do the same thing for that second equation there, or inequality. So it would be, should have left more space on our page. 30n plus 15b is less than or equal to 1,200. Same thing, want to solve that guy out for b, right? So if we're doing that, minus 30n from each side. So we have 15b is less than or equal to, that'd be negative 30n plus 1,200. And then to get rid of the 15, 5 by 15 on each side. So b less than or equal to, that would be negative 2n plus, it comes out nice to be 80. And that's another one we can use. And then those other two are good to go. We don't have to mess with those at all. Okay, so now let's get graphing these. So the tricky thing with this one is, so this y-intercept's all the way up to 200. We can count here and go all the way up to 200, but it's going to make our graph like really, really small. And it's going to make it kind of hard to see. So instead of going all the way up to 200, I'm actually going to count by tens. And I'll kind of show you how to get your numbers if you're not going all the way up. But I'm going to count by tens each way. So get that labeled. Okay, so like I said, for this first one here that we're going to graph, that y-intercept is 200, which is going to be like way up top here. But what we can do instead of just starting at 200 and doing our slope there of negative 10, you can also use your calculator on some of this stuff. So There is a way to do the inequalities on the calculator, but truthfully, I think it's just as easy to do it by hand if you've got to do it by hand anyway for like your answers or whatever. So I don't usually do it on the calculator. You can technically do it on the calculator. So like if I go to my y equals like normal, I would just type this in as is. So like -10 x plus 200. So I'm just going to graph it like I usually would. So when I hit graph there, probably not going to show up, right? Because my number's up to 200, which is like huge. So what I could do is I could change my window here to stuff that's going to be like more reasonable to my graph. So we know that we're not dealing with any negatives, right? So we can change like our x minimum to 0. Same with our y minimum because we're not dealing with any negatives. And then our x max, I'm just going to take mine out to the same things both ways. So I'm going to take this one out to 200, and I'm going to take my x out to 200 as well, or my y out to 200 as well. And when I graph it, it should show me up a line there. Again, that's just kind of hard to see because it's up so high there with the 200 and it's such big numbers. So to get this to do where it does the shading stuff, what you can do is if you go back to that y equals button and arrow over there, so see how these are all like little lines here? That tells you how it's graphing those. If you arrow over to those, it should be like flashing when you get on top of it, whether you got a new one or an old one. The new one, it looks the same. So I'll go -10 x plus 200. So when you go over to this one, you hit enter there. If you hit enter on the old ones, it'll just start switching those things. So you would have to know if you're shading on top or on bottom of that line for you to be able to like select one of these. So see how that one's flashing on top? That would shade on top of that line. This one's going to be a shade on bottom, so I'd have that there. You can also do that on the new ones. If you hit enter on that and then arrow down to this one that says line, you can arrow over there and do the same thing. It's hard to see. But same thing, you would just hit enter on that, and then I go down the line and I just use those arrows to go back and forth. It just graphs it a little different. So then when I go back and I hit my graph button there, see how it kind of just shaded that in underneath there? But you would have to know before you pick one of these things if it shades above or below. There is a program on my old one that I can turn on under the apps that's like inequalities or something like that. But I couldn't actually find that on my new calculator, so I'm not sure if it's something you have to download on the new calculators or what the deal is. But there is another way you can do it too, but it drains the battery, so I don't ever use it. But again, it's just as easy to graph these by hand, so I typically don't even worry about the calculator on them. But I can help you if you want to do more calculator stuff with it. But for our purposes here, we just have to come up with some points that are actually going to show up on our graph that we can use. So what I would do is I would just go to my table, and I would just kind of scroll through there for some points. So like we were talking about before, we know our y-intercept is going to be 200, but that's going to be way off our graph. So what I would do here is I would just scroll through to stuff that is going to be on our graph. So like 100 is the first one on our graph, so that could be a point that we use. So we could use 10 and 100 as a point. So I'm going to use a color to do this. I'm going to do it by, I did my color by both of those equations, so I knew that they were like the same thing. So my first point there, it told me 10, 100, so I'd go over 10, up 100. And then here, what's a little bit tricky is our x is counting by ones here, but our graph here is counting by tens, so you can either change it or you can just scroll to where it's like the next one. So their x at 20 is at 0, so it actually drops down there pretty quickly there. So we're only going to have two easy to graph points on there. So we'll have 10, 100, which is at the top of the graph, and then 20, 0. And I just pulled that stuff from the table. Okay, so then what we also have to decide is we have to figure out if that's going to be a solid or dashed. What do you think, solid or dashed? Solid, because it's got that equal to line underneath, right? So we'll just make a solid line. Both of those points. Okay, and then shading wise here, what are we thinking? We would shade under it, yeah, and if we weren't sure, again, I should have left more room on this. If we weren't sure, you can plug in that 0, 0 there, so you could do like 500 times 0 plus 50 times 0 and see if that's less than or equal to 10,000. Well, there's 0 and 0, that'd be 0 is less than or equal to 10,000. Well, is that true? Yeah, it would be, right? So if that's true, we would want to include that 0, 0 in the shading, so agreed. It would be all our stuff underneath it there. Okay, so that's our first one. Like I said, that was just kind of weird because it's such big numbers. This one, everything should stay on our graph though, which is nice. So I'm going to switch colors here. put those little colors by that second one, and then also the one we solved, so we know that those match up. Okay, so then this one, our y-intercept is 80, slope of -2, so we go out to 80 for our y-intercept. Slope of -2, what are we going to do?
Down 2.
And which way over?
Right.
Right, yes. So we'll go down 2 and right 1. Now, technically here, similar to yesterday, technically this is going down 20 and over 10, but isn't that the same? Yeah, so that works as long as you're counting by the same things. If you're not counting by the same things, that's where you run into trouble. But that's why I choose to keep it counting by the same thing. So down 2, right 1, do that a handful of times. And it should get you down to where you're meeting that bottom line at 40. Okay, then we thinking solid or dashed? Solid. Shoot that line through from the 80 to the 40. Okay, then same thing there. We thinking above, below, what are you thinking? Below again, so there we could do the same thing, so we can plug in that 0, 0, so like 30 times 0 plus 15 times 0 less than or equal to that 1200, so 0 is less than or equal to 1200, which we know that to be true, so that would mean we include that 0, 0 in our shading. Okay. Then our next two there, so this is where you could either do one color or two colors. Sometimes I'll do both of these in the same color. If you want to do them separate, you can, or the same color, whatever, it doesn't matter. So here we've got B is greater than or equal to 0. So these are our B values going up and down. So our 0 at our B value would be across the bottom there, and we want all our stuff that's bigger than that. So our line's going to be kind of across that x-axis there. If it's equal to, solid or dashed? Solid again. I feel like we've got a lot of solids. Okay, I did that in my third color. Okay, and then this one's a nice one because if it's B is greater than or equal to 0, where do we find values greater than 0? In this case, above it, right? So we just go through there, shade that stuff. Okay, and then I'm gonna go fourth color here, or you could just use the same color as you did there for that one. And similar concept here, n is greater than or equal to 0. Same thing, except for it's going the opposite way. So our n value being 0 would be like the y-axis. Solid line there again, because it's equal to. And then where do we find stuff greater than or equal to 0 in this case? To the right of it. Getting quite messy in here. Okay. So now what we need to focus on is the area that's our actual feasible region that's most important to us. So that's our, in this case, like all 4 shadings are crossing each other. Okay, so what are you thinking for that area? Yeah, so kind of like starting here, kind of this little corner in there, and then kind of going to that 20 because that line there is going to cut that off. So like we did yesterday, I usually kind of go through there and darken that up a little bit just so you can kind of see that that's our actual area we're talking about. Again, it gets super messy in there. Okay, so that's our feasible region. And then I don't know, yeah, so it says find the vertices of that region in ordered pairs. So vertices, like we were talking about yesterday, there are corner points of that feasible region. So like here, we have one corner point there at like 0, 0. You would have another corner point there at like that 20, or that, yeah, 20, 0. Your crossing spot up here, which if we can't see it clearly, we might have to use our calculators to find that actual intersection point. And then we'd also have one here up at this 80. So we'll have those 4 corners there as our vertices, okay? And then you can just list those out. So vertices would be 0, 0, 20, 0. We don't know that one quite yet. We'll use our calculator on that one, and then this other one would be 0, 80. Okay, so because that one seems like kind of in no man's land there, what I would do is I would just use my calculator on this, and I would just go to my y equals. I'm going to get rid of the shading thing, so you can just go back to it and keep hitting enter there until you get back to like the normal lines, and it'll go back to normal. So I'm going to type that second one in there, so -2 x plus 80. Graph that. So we get something like that, which matches our picture relatively, so that looks good. And then we got to find that crossing spot there, so I'd just go second trace down to intersect. And then with this one, there's only two lines, so you can just hit enter 3 times for your curves. And it tells us that that intersection spot is at 1550. And we might have been able to figure out that from our graph too, but it just gets so sloppy in there, we might as well use our calculator. Okay, so that's similar to what we were doing yesterday, right? So now the new thing on this, they're gonna ask us to use those vertice values to actually like maximize or minimize values here. In this case, it's gonna be maximizing values because we're trying to like make a profit. Like our goal when we're selling stuff is to make the most money possible, right? Ideally. So this is a maximizing one. The minimizing ones look a little different. There's not a good picture in the book of a minimizing one, but usually instead of the shading being underneath, the shading would be on the opposite side instead. So like you'd be looking at stuff where it's kind of shaded this way and your points would be a little curved, a little different there. But most of them you're gonna see are these maximizing ones. But anyway, so for part B, it says Lisa's weekly profit is $8 on each necklace and $5 on each bracelet. How many of each type of those jewelry things should she make and sell them? Can't just make them, gotta sell them too. Each week to maximize that profit. Okay, so what we're gonna do is we're gonna take those vertice values we used and we're gonna use those with the $8 and the $5 to see which gives us the biggest gain. Okay, so I'm gonna start by making a little equation here for profit. So I'm gonna go profit is equal to, for every necklace we're getting $8, so that'd be 8 times our number of necklaces, plus every bracelet we sell is $5, so 5 times our B. And then what you're gonna do is you're gonna take these vertices that we had up here, so these values, and you're gonna plug them in to those spots right there, okay? And then your goal is to figure out which of those has the highest profit. Now here, when we do 0, 0, it would be like P is equal to, so this is, I should have wrote 0, 0 above it. So for 0, 0, it'd be P is equal to 8 times 0 plus 5 times 0. If we're making no bracelets and no necklaces, are we making any money? No. So are we maximizing our values there? No. So that one's really not super helpful, but it's still one of the things we're supposed to check. So that would be like our P being $0, which we know we can make more than that with these other ones. So then I just go on to the next one. So in my next ordered pair there is 20, 0. So same thing. So in for the N spot, I'm going to put the 20. In for the B spot, I'm going to put the 0. So P is equal to 8 times 20 plus 5 times 0. So we know there 5 times 0, just 0, right? 8 times 20. What's 8 times 2? Plus a 0. 160. So $160. So that's much better than the previous one. Next one we're checking there is the 080. So same thing. So profit is equal to 8 times 0 in this case, plus 5 times 80. So that's 0 again. 5 times 8. 40 plus a 0, 400. So that's a profit of 400, so that's pretty good. And then we'll check our last one there. So that last ordered pair was 1550. So P would be equal to 8 times 15 plus 5 times 50. Okay, anybody got me 8 times 15? I think it's 120, isn't it? Because it'd be 8 times 10 is 80 plus 8 times 120. Thanks, Summer. So 120 plus, and then 5 times 50? 250. Add those together, 370. Okay, so then what we're doing is we're trying to minimize, or not minimize, maximize our profits here, right? So which of those situations gave us the biggest profit? Yeah, no. Yeah, we could go with that one, right? So I was going to agree with you. Yeah, so that one there with the 400 is our biggest profit. So if we make 0 of the necklaces and all bracelets, that's going to make us the most money. Now, realistically, if you're going somewhere and you're trying to sell stuff, is it probably good to only have one of the items? Probably not. It's probably better to have variety, but in the case of maximizing our profits there, that's the best option. Okay, so you get that book page assignment there. So 1 to 12, skip 3, 7, 8. On 10B, it says to use CAS. Don't use CAS, just graph that, okay? So 10B, it says CAS, just ignore that, just graph that one instead, okay? Okay, so we'll go over that stuff on